Welcome along to the video and to the wonderful world of biomes, or should that be a world of wonderful biomes. We're going to be looking at how biomes shape the planet, the way ecosystems are distributed within them, and the positive and negative impacts of human intervention, both around the globe and right here in the UK. Biomes are classifications used to describe a biological community that is formed in response to its shared physical environment. As with so many other aspects of ecology, humankind's urge to categorise the world around it is superseded by nature's never-ending ability to evade pigeonholing, and as such there's an ongoing discussion around exactly how many biomes there are. The number of recognised world biomes can vary from anywhere between 5 and 30, all depending on how precise you get with your classifications. In the broadest terms, the biomes that describe all of Earth's land cover are polar and tundra, temperate forests, both deciduous and coniferous, grasslands, tropical rainforest, desert and coral reef. Aquatic biomes, which cover 75% of the Earth's surface, are generally split into two categories, freshwater and marine. Abiotic factors do much to impact the distribution of the various biomes. Atmospheric energy flows like thermals and wind, and the characteristics of climatic zones play a large part in a biome's makeup, as do its altitudinal position and distance from the sea. Soil type, shade, and the gradient of land all dictate how things grow, which in turn shape the communities and ecosystems that form within the biome. Whilst biomes often predominate over large areas of land, they're not always exclusive, and different biomes can overlap, as is the case with polar and tundra. Polar deserts and tundra are found at the poles of the Earth, with Antarctica in the south and the Arctic in the north. Whilst they receive nominal rainfall, polar deserts are distinguished from true deserts by low temperatures and low evapotranspiration, or the combined process in which water moves between the Earth's surface and its atmosphere. These factors impact heavily on the biome's distribution, with very little life supported by the barren environment. Moving down into the tundra, the atmospheric energy flows are a little more welcoming, and whilst the frozen soil still makes it impossible for trees to grow, certain kinds of low-growing vegetation like moss, heath and lichen are supported. The strong winds, long winters and limited growing seasons present a hostile ecosystem to all but the hardiest of animals, and the subsequent dearth of droppings and dead organic matter means any soil that escapes the permafrost is nutrient poor. Alpine tundra share many of the same qualities, though the conditions are prompted by altitude rather than latitude. Air gets colder as it rises, so the land lying between the tree line and the snow line will suffer from the same scarcity of biodiversity as the Arctic and Antarctic. Even more challenging to the flora, higher winds cause soil erosion, and intense solar radiation causes higher rates of evaporation and transpiration. As their latitudinal position shifts southwards, biomes become more favourable, with temperatures rising and wind speeds dropping. Temperate forests tend to appear beneath the tundra and grasslands occur below that. Covering half of the Earth's land area, grasslands are recognised as the biggest of all land biomes. Benefiting from distinct seasons, good precipitation and predictable temperature variation, they engender great structural diversity and support the greatest aggregation of large animals on Earth, providing a habitat for everything from elephants to ferrets. They also support a huge range of bird life, invertebrates and symbiotic fungi. This breadth of community leads to deep, fertile soil and a wide range of plant life, although grazing animals and frequent fires mean that trees and large shrubs rarely feature, save for in riparian woodland found along rivers and streams. The nutrient-rich soil, which in the UK alone is thought to store more than 2 billion tonnes of carbon, has made them attractive sites for agriculture over the ages, and today only a small proportion of them exist in their natural state. During the 20th century, over 90% of lowland grasslands were turned over to agriculture, with government incentivised ploughing releasing untold amounts of carbon back into the atmosphere. Today in the UK, only 100,000 of a total 14.5 million hectares of grassland are unimproved or exist in their natural state. Another biome facing huge challenges from human intervention are rainforests. Rainforests occur in every continent except for Antarctica, though it's those found in between the tropics of Cancer and Capricorn that are called tropical rainforests. These are the Earth's oldest extant ecosystems, some of which are thought to have existed in their current state for around 70 million years. Rainforests provide a home to more than half of the world's plant and animal species, yet account for only around 6% of its land surface. This makes them amazingly dense with a 4 square mile area containing anything up to 750 species of trees. Trees can grow up to 200 feet tall, creating a 4-tiered structure. The emergent layer at the top, where widespread branches make the most of the intense solar energy. The canopy layer beneath, which forms a dense roof and creates a contained environment with a humidity of around 75% in the layers below. The understory, packed with large-leaved plants like palms and philodendrons, and thriving with mammals and insects who use the dim surroundings for camouflage. And finally, the forest floor, which is so dark it's extremely difficult for plants to grow, but supports a thriving community of decomposers such as termites, slugs and worms, which in turn attract larger predatory animals. These complex ecosystems are at a constant threat from deforestation, especially in Brazil, where since 1970 a staggering 700,000 square kilometres have been cleared by cattle ranchers, farmers, miners and illegal loggers. This devastation has horrific ramifications for the rest of the world, as not only are important oxygenators removed, but carbon stored in both trees and land is released through burning and ploughing. Here in the UK, our biomes are largely temperate, with habitats including grasslands, bogs, broadleaf and coniferous woodlands, coastal salt marsh, sand dunes, heathlands, fens, marsh, swamp and scrub. The Tees X line, an imaginary line that links the mouths of the River Tees in the northeast and the River Exe in the southwest, loosely marks a change in the bedrock that informs the habitats above. To the west of the line lie the highlands, formed by harder, igneous and metamorphic rocks, Precambrian sandstone and limestone. These ancient rocks tend to give upland landscapes, with hills, mountains and moors receiving wetter weather and creating many of the UK's main rivers. The lowlands to the east of the line are largely formed of flat-lying sedimentary rocks formed during the Carboniferous period. These softer rocks give low-lying, gently rolling landscapes, richer soil and greater structural diversity. Here in Lesnes Abbey Woods in southeast London, we're well into the lowlands to the east of the Tees X line. The ancient woodland sits on the borders of Bexley and Greenwich and lies largely on a bed of free-draining, slightly acid, loamy soil. To the north, the soil becomes clay-heavy, formed by the floodplain of the River Thames. The higher reaches of the undulating woodland boast very acid, sandy soil, created 50 million years ago when the area formed a bed of a lagoon. Millennia later, these sandy beds still offer a tangible link with the Eocene, with an endless treasure trove of fossils found just beneath the surface. As well as sharks' teeth and shells, amateur excavators have unearthed the remains of over 40 species of mammal, reptile, fish and early bird. Such as the proliferation of fossils in the beds, modern-day diggers are asked to limit their hauls to 200 grams. The woods take their name from the abbey built in 1178, though features in the land suggest human activity stretching back millennia, from the Dean holes, or chalk pits, to the Neolithic tumulus, the possible site of a Bronze Age burial ground. In recent times, the tumulus made an attractive launch for BMXers and mountain bikers, and has since been cordoned off to prevent any other further wheel-inflicted erosion. The woods hold various conservation designations, including a geological SSSI, that's a site of specific scientific interest, and a site of metropolitan importance. They are recognised as both RIGS and LIGS, which is to say regionally and locally important geographic sites. They are listed in the Priority Habitat Inventory as deciduous woodland, and the National Habitat Network recognises them as ancient woodland, meaning they have persisted without intervention since 1600. This uninterrupted ecology provides a vital home for a complex community of plants and fungi, and in the case of Abbey Woods, one of the largest displays of wild daffodils in the southeast of England. Considered clearing of the understory has helped with the spread of foxglove and bluebells, and recently Aquilegia, or Granny's bonnet, which has been found self-seeding along the pathways. This has presented a challenge, as the pathways, unlike the rest of the woods, are not maintained by the park rangers. Instead, they are the responsibility of the council, whose cost-effective practices generally favour strimming and brush cutting over a more considered conservational approach. The delicate nature of the topsoil horizons, both in the fossil beds and around the woodlands, mean any work in the woods must be approached sympathetically. Instead of using modern machinery to pull out logs, heavy horses are used. This traditional method of extraction is much less impactful, as the horse's weight is constantly transferred between its hooves. It can also help with the controlling of understory, as pernicious invasive species like bracken and fern are crushed or bashed during the process. As there are no felling agreements in place in the woods, this process is only used when coppicing for woodland management rather than timber extraction. The careful conservation of this important site isn't limited to the woodlands. An area of historical heathland has been restored by clearing out woodland succession, with conservators aiming to achieve 10% canopy cover by removing many of the large trees. A number of ancient Quercus petrae, or sessile oaks, have been left standing. Generally preferring wetter upland areas, the trees aren't particularly common in the southeast, and these specimens are thought to have been planted by monks who knew they'd handle the acidic soil on which the heathland thrives. Oaks support more wildlife than any other native broadleaf, and while sessile oaks are less common than their highly profiled cousins Quercus pedunculus, they provide an equally rich microhabitat. As well as jays and squirrels, which famously feed on their acorns, there are 2,300 species thought to be supported by oak, more than 300 of which depend on them specifically. A deciduous tree, the flowers of the sessile oak are favoured by all manner of insects and invertebrates, including the caterpillars of the purple hair-streaked butterfly and the dark crimson underwing moth. With the trees providing such a bountiful food source and the heather offering protective ground cover, there's been a noted increase in secondary consumers since the heathland's clearing. Hedgehogs have been recorded for the first time this year, although this may also be linked to the drought experienced earlier in the summer. Sadly, there's also been an increase in invertebrates carrying pathogens, again connected in some way to our ever-changing energy flows. Oaks throughout the woods, especially mature specimens, show the distinctive D-shaped holes created by the oak splendor beetle, an insect closely linked with acute oak decline. This disease is caused by an as yet unknown bacterium and can lead to the death of trees within 5 years of presenting symptoms, most often characterised by dark fluid oozing from lesions in the bark. There have also been recorded instances of oak processionary moth. However, whilst their feeding habits cause significant damage to the leaves, they don't necessarily affect the wood. Their venomous hairs are a much greater threat to humans, causing skin irritation and asthma. By far the most abundant tree species throughout the woods, sweet chestnut are also at risk from insect-borne infection. The oriental gall wasp attacks the leaves of sweet chestnuts, leaving them prone to chestnut blight, a parasitic fungus that has caused widespread devastation across America and Asia, but only recently been identified in the UK. A statutory plant notice is in place in the Hurstwood, an area that was separated from the rest of the woods with the construction of the new road late in the 1800s. This intervention effectively split the wood in two, creating a barrier for smaller land-bound animals and limiting their habitat. Over time, this kind of enclosure will have an adverse effect on the genetic diversity of those species contained within, resulting in weaknesses in their immunity, resilience, and life expectancy. Counter-interventions like crossing paths and tunnels will help to correct this, providing animals with links to the rest of the woods and to a greater number of mating partners. Thanks for watching my video. I hope it's explained a little bit more about biomes, and I hope it's encouraged you to go and visit Lesnes Abbey Woods in South East London. I also hope it's enough to get me a distinction, but I'll leave that up to you. Okay then, see you!